So these are the final moments. This is the figure and this is the analyzed part. How we came on to these moments? Keep watching this video with me, myself Smriti Gupta, and you are watching SimpleCivil. So in this video we are going to analyze this frame using moment distribution method. So in this video we are going to analyze this frame. So first of all, my first question is how we understand that this is a sway or a non-sway frame. For that you have to check number 1 for the supports, number 2 for the loading condition, number 3 the geometrical condition, number 3 the rigidity and the placement of the load. So in this question our loading is not symmetrical. So what we have, our loading is not symmetrical. So we have a left side sway condition because our loading is mostly on the left part. So now first step is your FEM, that is fixed end moment. So on the legs there are no loading, so we have A, B, C, D as your 0. Now coming on to the BC part, that is the story part. So we have fixed end moment as MBC. We are using this formula because our loading is not symmetrical, so we are using this formula. Now how we came to know that this is positive or negative? So this is our loading, this is the deflected part, these are the moments which are trying the beam not to deflect, they are resisting the deflection of the beam. So this is coming positive, negative, because we are considering our anti-clockwise moment as positive. Clockwise we are considering as negative. I am just substituting the values of W and L in the equation, in the formula, and here we are with our fixed end moments. Now we are coming on to the step number 2. So step number 2 we have rotation factor and distribution factor. So in this frame we have 4 joints A, B, C, D, in which B is connected to 2 members and C is also connected to 2 members. So what we are going to do, we are going to find out the distribution factor. What is a distribution factor? Distribution factor is a factor which decides which member will be taking what amount of the unbalanced moment. And how we decide that? Distribution factor depends on the rigidity and the length of the member. It is practically on the geometry of the structure or geometry of the member. For that we have to make a table like this. So in this table we have joint, member, rotation factor, sum and distribution factor. So first we have to identify what are our joints. So our joints are B and C. Then we have to identify what are the connecting members. So with the B we have BABC, with the C we have CB and CD. With that we should know that what is a rotation factor. Rotation factor is a factor. Let me draw it for you. So this is a fixed beam and this is a fixed and hinge beam. So if some moment is applied, the beam will be rotated somewhat like this, and these are the resisting moment which are applied, and the value of this is 4EI by L, and for the hinge it is 3I by L. Since in this question all the supports are fixed, since B and C are the intermediate joints, so they will also behave as the fixed because all the intermediate joints behave as fixed. Now our next step is we'll be substituting the value of EI and L in all the rotation factor. So we have this twice EI and the length is given as 6. We'll be substituting like that only and just put the things in the calculator and find out the final moment. Now in the sum we have to just simply sum up the rotation factor. Distribution factor is your RF upon the sum. Simply put the RF divided by the sum and you will be getting the distribution factor. Always remember, distribution factor at one joint has to be equal to 1. So adjust your decimals in such a manner that the final result is coming out to be 1. So this has to be 1 and this also has to be 1. Next, this is a frame I have taken. So this is your 4 and these are the fixed supports. So I am making a little bit fix here. These are the fix, I'll be putting it, and this is the loading. So your frame might deflect in this manner. So since no horizontal loading is there, so your frame, because of the geometry and the unsymmetrical loading, this frame might deflect somewhat like this. We have to check, we have to calculate your sway frame, your horizontal reactions are coming in which direction and what amount. In this we have taken just example of the sway frame. Now how to analyze the frame? So sway frame is generally analyzed in two manners. So we have to make the table two times. Yes, we have to make it two times. One is your non-sway with the loading and one is with sway without loading with the geometrical conditions. So whatever geometrical conditions we are having, we'll be using that and we'll be finding out the final results. So now we are coming on to the moment distribution table. So from here we will be substituting the value of df, that is distribution factor, into the table, and this is your df. Now your fixed end moments, so what fixed end moments came, we have to write that. So I am writing df fixed end moments, balancing. Next is your carryover. So this is the format which we are going to follow. So next is your balancing and then again your carryover. The next step is we have to put the value of the fixed end moments. So these are the two fixed end moments. On the leg part or the column part, we don't have any fixed end moments. So this is just simply I'm substituting the values of FEM. Now you can see that at B joint the unbalanced moment is coming out to be positive 44. So what I am doing, I am putting a negative sign. Whatever unbalanced moments are coming, you have to put the opposite sign. Simply multiply it with the DF and write it down. So unbalanced moment multiplied with the DF and you just write it down. Next is we have to carry over this unbalanced moment. So what is the funda or what is the formula for shifting or distributing the unbalanced moment? So if we have a fixed joint, so fixed joint will be donating or transferring the unbalanced moment to the fixed joint. With the pin joint or the hinge joint, no transfer will be made. Fixed joint can only take, it will not give you back. Fixed joint will not give you back. So in this one, B and C, so B will be transferring to A, AD will not be transferring it back to B and C. So now I am just simply transferring, so half of it with the sign. So if it is negative or positive, half of it with the sign you have to transfer. So just simply put it in the calculator, divided by 2 with the sign you have to transfer. Now unbalanced moment coming on to B and C are this much. I am putting opposite sign. You have to always remember that you have to put the opposite sign while distributing the moments. So I am just substituting and putting the opposite sign. So unbalanced moment into your DF will give you the answers. Again we'll be repeating the same thing. So these are the balancing moment. Now we'll be putting the carryover. Carryover is your moment divided by 2 with the sign, positive, negative, whatever. You have to distribute it with the sign, and here we are. We have done this part. So I am just little bit forwarding the video little faster so that you can understand. You have to repeat the same procedures at least 4 times until the moments left side and right side of the support is coming equal and opposite. You have to repeat the same procedure. So opposite sign multiplied by DF, then carry over. You have to just carry over it. Carry over with the sign. You have to do it like this. Now unbalanced moment, opposite sign, again multiplied with the DF and write it down. You have to multiply it with the DF and you have to just simply write it down. So now your next step is you have to put that in calculator and half of it you have to transfer it to the next fixed joint. So this is how we are doing this. Now last is your balancing. So we have to do this, and we have already done our 4 iterations. Now we'll be just calculating the final moments. Final moments, you have to sum up the columns, you have to sum up all the moments what we got, including the fixed end moments. So just sum up all the moments from top to bottom, including your fixed end moments, and whatever moments came up in the column, you have to just simply sum up all the moments which are coming onto one column, including your fixed end moments. So you can see that left side and right side moments are coming equal and opposite. That is, now your joint is coming into equilibrium and there are no unbalanced moments. So these are the final moments what we got from here. So this is the moments what we have started, and after the calculations we came up on to. After this, we'll be calculating the horizontal reactions which are generated because of these moments which are coming on to the support. So for that, we are going to make this frame with the horizontal reactions. So we are just simply, I am not writing it onto the frame. So these are the moments what we got, and I am just taking a moment at B point. So this is coming clockwise we are taking as negative. So your first 2 reactions are also your clockwise, so I am putting it here, negative and negative, and with this we are going to calculate your HA. Now what we are going to do is just simply substitute the value what we came up in the question, just simply substitute it and find out the value of HA and HD. So HA, HD are the forces or the reactions, horizontal reaction which are coming up because of the moments. So what we are going to do is, we are simply going to take the moment at B and C point, and we are going to sum up all the moments and calculate the value of HA and HD. Now we are going to calculate the value of X. So X is simply the sum of these 2 which are coming onto the structure. That is the combined effect of the reaction onto the structure which is giving a sway force. Let's take an example of a beam which is sinking down with a delta amount. Now what is happening? Moments are generating because of the sinking of the support. So these moments are both anti-clockwise, that is positive, and the amount is 6CI delta by L square. So this is the amount with which the moments are generated. Now we are taking example of our frame. So let's suppose this frame is going right side deflection. Since the example what we have taken is somewhat like this, what we have concluded that these kind of moments will be generated onto the frame. In this question, since we have I as same and length is also same, rigidity and length are same, so the amount of moments which are coming onto the structure will also be same. So 6CI delta by L square on both the legs, on all the 4 joints will be coming out to be same amount of moments will be coming up. Now what we are going to do here is, since EI and delta value is not given in our question, so we have to assume a random value for this question. So since EI delta is not given, I am in this question, I am taking 50 as my EI delta. So I am going to just simply substitute the value of EI delta. So my fixed end moment or my rotation value coming out to be this much. So these are all positive. I am putting that in the moment distribution table. Again same thing will be doing. I am putting the DF, I am putting the fixed end moments, and I will start with my moment distribution table. So like what we have done before, unbalanced moment which is coming on to the support, multiply by your DF will give you the next moments. This will be simply carrying it or distributing it on to the next fixed support. So I am just going to shift it or distribute it to the next fixed support, and here we are. So whatever undistributed moments are coming, opposite sign we have to put. Always remember, opposite sign we have to put the moment multiplied by the DF, and we have to just simply write it down. So So the unbalanced moment coming on to the joint multiplied by df, and we are going to just simply write it. Now shift it or distribute it, transfer it to the next neighboring fixed joint only. Hinge joint we are not supposed to transfer the amount. So here we are, opposite sign, same thing we have to repeat at least for 4 iterations. So here we are, at least for 4 iterations we have to do the same procedure. So shift it, divided by 2 with the sign, shift it, divided by 2 with the same sign, always on to the next fixed support only. And nothing will be coming out of a fixed support like AD, nothing will be coming out from them. So whatever unbalanced moments are coming, multiplied with the DF and do the same procedure. So this is our 4th iteration what we are doing. So I am just going to balance the final moment what we are coming up. So opposite sign, multiply by DF, and you can see the amount here. Your moments I have reduced to 0.0 something. This is a small value. So after this what we are going to do is just simply sum up all the moments what we got, starting from the fixed end moment. Everything what a column is containing, all the things we have to sum up and we have to write down the final moments. Now you can see at B, left side right side moments are equal and opposite. So we have started with the positive 18.75 and now our balanced are equal and opposite. So here we are, these are the final moments what we got from the sway analysis. Now our next step is same what we have done in the non-sway analysis. We are going to find out the horizontal reactions which are coming up because of the moments, and we have to again calculate the final sway force which is acting because of these two. Here what I am doing is I am taking a moment at B point. So this is your clockwise negative and I am as it is taking both the moments here. Same procedure we have done with the sway frame. So here HA I am calculating. Next I will be taking moment at the C point, and the same thing we will be doing, taking moment at the C point and just putting up, summing up all the moments what we got. So adding these two will get the sway forces. So this is coming out to be this much in kilonewton. So these two are in kilonewton. So your X dash, this is your X dash, that is the combined effect of both the horizontal reactions which are coming, and this is causing the sway force. So this is it. So this one, and so what we are doing here, since we have taken one assumption, EI delta we have taken as 50, this was the assumption. So we are now going to take the combined effect of sway and non-sway frame, and we are going to multiply this with the moments we got from the geometric condition. So here I am writing all the final moments what we got. Final moments will be your non-sway analysis plus this is the correction factor that we have calculated X into the sway moments what we got. So here I am calculating and adding this correction factor into the moments what we got from the sway analysis, and I am listing down, writing down all the moments what we got. So you can see that BA and BC. So this is the corner BABC. So you can see that it is coming equal and opposite. Here we are writing all the moments, final moments, and you can see that at the joint the left side and right side moments are coming equal and opposite. So we are writing all the moments here, and this is how we have calculated, and we are done with the final calculations. For more such videos, do subscribe my channel. Thank you for watching.